Hi guys, you're welcome back to another interesting evaluation of integral. Here we have x squared on 1 plus the square root of 1 minus x squared. In order to integrate this, you may do the substitution of the sign substitution or the cos substitution if you like. But the easiest way to do this is to rationalize it first. So when you rationalize the denominator, you'll be having the integral from 0 to 1 x squared on 1 plus the square root of 1 minus x squared times the conjugate of the denominator, which is 1 minus the square root of 1 minus x squared on 1 minus the square root of 1 minus x squared, all dx. Okay, now this should be equals to this times this, so we have the integral from 0 to 1, okay, so x squared times, or what we have here, 1 minus the square root of 1 minus x squared, bracket close, all on, then this and this multiplying, you get the difference of two squares, so 1 minus the square of this, which will be 1 minus x squared dx. So you'll be having this should be equals to the integral from 0 to 1, okay, so x squared bracket open 1 minus the square root of 1 minus x squared bracket close on 1 minus 1, you open the bracket, you get 0, and this will be x squared, then dx. Okay, so you have this should be equals to the integral from 0 to 1, then you have 1 minus the square root of 1 minus x squared bracket close dx. So you now have, you expand, okay, so you'll be having this should be equals to dx 0 to 1 minus the integral of the square root of 1 minus x squared dx from 0 to 1. Okay, so we know that the left hand side, when you integrate, you get x, so that's, you evaluate, you get 1 minus 0, so you get 1. That is no more a problem. So this is what you have to do now. Now in solving this, we need to introduce sign substitution or cosine substitution, anyone you like, you prefer. Okay, so how I teach this is that, you see, the expression here stand for the y, is the y value on the xy plane. Okay, so the y, the function, this is the function of x, and the function of x produces the y, so that means that on an xy plane, okay, you'll be having, let's say a point, you'll be having a distance joining the 2 points x and y. Okay, so you have x here and your y here. Okay, and based on this, we have our hypotenuse, okay, to be 1. That is the longest length. Okay, the longest length to be 1. So when you're looking for y, okay, that will be y square will be equal to the square root of, sorry, y will be equal to the square root of 1 minus x square, which is from the Pythagoras theorem. So 1 square equals y square plus x square. So something like 1 square equals y square plus x square. So you change subjects, you make y the subject, you get this. So it's the same thing as this. So in this case, since that is the same thing as this, okay, we decide to find an expression in terms of x and 1, because the y shouldn't be there. If you put y there, it will be very difficult for us to integrate. Okay, so we get an expression in terms of 1 and x, so using the angle. So we use an angle, put an angle here, or you may decide to put an angle here. So let's put an angle here. If you put an angle here, you'll be using cos. If you put an angle here, you'll be using sine. So I'm putting an angle here so that I can use sine. So you'll be having, you can check my videos, other videos, I explain the cosine substitution perfectly there. So you have, if the theta is here, so you have opposite on hypotenuse. So that means that sine theta should be equals to opposite x on 1. So x should be equals to sine theta. So that means we substitute it into this. Okay, so we'll be having the integral of from 0 to 1 square root of 1 minus, instead of x, okay, it should be sine square theta. Okay, now when you differentiate x in terms of theta, so we'll be having cos theta. So you know that here is the x, so we make the x the subject. So we'll be having the x equals cos theta d theta. So we put that into this, okay, we put that the x, okay, should be this. So we'll be having cos theta d theta. Okay, perfect. Now the 0 and 1, the limit should also change. So these are for x's. Okay, so we also have to change that. So when x equals, so we have to find, so when x equals 0, okay, so we'll be having 0 equals sine theta. So that means that the sine inverse of theta, the sine inverse of 0 should be, so theta will be equals to 0. Sine inverse of 0 is 0, so 0 degree. So here theta equals 0 degrees. We do the same thing for 1, okay, 1 equals sine theta. So sine inverse of 1 should give us 90 degrees. 90 degrees. Okay, so we can leave it in the radian form. Okay, so we pi radian, so we have pi on 2. Okay, so that should be pi on 2. All right, now you should know that this is an identity. Okay, so we know that, but cos theta equals the square root of 1 minus sine square theta. So we put that into this. So we're having from here the integral from 0 degrees, or it's in radians. So from 0 to pi on 2 should be equals to cos theta times another cos theta d theta. Okay, so we move that. Okay, so we'll be having the integral of cos squared theta. Now cos times cos is cos squared, so cos squared theta d theta from 0 to pi on 2, and this should be equals to, note that the cos squared theta as an identity, you have to use an identity to also solve that. Okay, so I also have a video on that one as well, so you may check it out. So cos squared theta is the same as cos 2 theta, so we use a double angle for that. Cos 2 theta plus 1 on 2, so from 0 to pi on 2 d theta. So we now we can easily integrate. So this should give us, so we take the constants out here, so that's half, 1/2, okay, from 0 to pi on 2 cos 2 theta plus 1 d theta. So we integrate now this. So when we integrate this cos 2 theta, we'll be having, so 1/2, okay, bracket open, you integrate this, you get sine, okay, you get sine 2 theta, okay, sine 2 theta, but there is 2 theta, so times 1 or 2. So I've also done the integration of this one as well, so you, in the proving for this, is just when I was proving this, okay, so you can check out the video. So you have 1/2 times sine 2 theta, then plus, integrate this, you get theta. So you have this, all this there, so we use the limit pi on 2. Okay, so now we can do the substitution. So when you substitute, you have half of sine, so 2 times pi on 2 plus pi on 2, okay, then minus the same thing, half of sine 2 times 0 plus 0, so everything. So in short, this will give us 0, okay, and this, yeah, this should give us 0, and this should give us so you have, this will be equals to half of, now this will be sine pi, so sine pi should give us 0, okay, 0, then you'll be having pi on 2, okay, pi on 2, so this one will be 0, and you'll be having pi on 2. So we should be pi on 4, so we'll be having pi on 4, but do not forget we already have a 1 from the beginning here. When we differentiate this, okay, you differentiate the x from 0 to 1, you'll be getting x, so 0 to 1, and that should give you 1 minus 0, which is equal to 1. So the final answer will be 1 minus, yes, it's minus 1 minus pi on 4. Okay, that's minus here, minus sign. So 1 minus pi on 4. And that should be your final answer. So that means, let me write everything. 0 to 1 x squared all on 1 plus square root of 1 minus x squared dx should give you equals to this. So you have this. Thank you.